Welcome to everybody who's joining us. The Rural Broadband 101 webinar. Happy to have you. Okay, I think we're going to get going. So welcome and thank you for attending our Rural Broadband 101 webinar today. My name is Pam Becker. I'm the Executive Director of the Foundation for Rural Service, or FRS. We're the philanthropic arm of NTCA, the Rural Broadband Association. So FRS, through scholarships, grants, and a variety of educational programs, we focus on educating rural youth, encouraging community development, and introducing policymakers to challenges that are unique to rural communities. So I have just a few housekeeping items before we get going. Plus, I'll give people more chance to get logged in here. So we are recording this session, so it'll be available after today. If you learn about somebody who wasn't able to participate but wanted to get the same information, let us know. We will also send you the slides that Stacey's going to be using, so there's no need to do screenshots or take frantic notes. After we're done, we will send you an email with all the slides and the information. And we're going to be leaving time at the end for questions. So feel free to type your questions in the Q&A section of the Zoom. You can do it during the presentations or at the end, and then I will pass them along to our speakers. They'll probably answer the questions at the end, but feel free if you think about them as we go. So there we go. Now, it's my honor to introduce our presenters. I want to go quickly because we have a lot of information to cover here and they are going to be more interesting. So first, Stacey Brigham is Regulatory Director for TCA. She's in Colorado Springs, Colorado today. TCA provides business consulting services to rural broadband providers and their affiliates. She joined TCA in 2007 and works directly with clients to educate and advise them on federal and state telecommunications and broadband policy matters. She assists clients with advocacy and provides expert witness testimony on critical issues in both federal and state jurisdictions, including federal universal service reform, various state high-cost fund reforms, consumer protection, and wireless spectrum regulations. You're really going to enjoy Stacey. Then we're going to hear from Keith Gabbard, who has served as CEO and General Manager of People's Rural Telephone Cooperative since January 1996. After receiving a bachelor's degree in business administration from Eastern Kentucky University, he came back home to McKee, Kentucky, and began working for PRTC that same month. He's been with the company for 44 years, and under his direction, PRTC has grown from offering only phone service to providing broadband and HD TV cable, utilizing a recently constructed state-of-the-art fiber to the home network. Keith is a very active leader in his community, volunteering and serving on numerous local, state, and national boards, including as the 2021 chair of the FRS Board of Directors. So I'm especially happy to have Keith joining us today. We hope you have a great session. We hope you learned some good information, and feel free to put those questions. All right, Stacey, take it away.
Well, thank you for that introduction, Pam. And as you mentioned, we have a lot of information to cover today. So I'm going to be going through this information rather quickly. If you have additional questions or if there's something that we're not covering today that you are interested in, I truly do hope that you take advantage of that Q&A and send those questions our way. So with that, let's begin talking a little bit about Rural Broadband 101. Just a couple of things we wanted to get cleared up right away. The first thing is that the internet is not necessarily a thing. What it is a network of networks. And we're going to talk a little bit more about what networks are and how you all access the internet as we go through this information. So essentially, just keep that in the back of your minds that the internet is a network of networks. So what is a network? A network is basically a kind of exactly what you're thinking of, right? It's like a web of various interconnections. And networks are a lot like trees. You see this tree here that I have on the left of the screen. And what you see is a trunk, you see roots, you see branches. There's various sizes of things as the tree is growing and it's building itself out. Networks are a lot like that very same thing. They're basically designed in a way to get connections to to outside or to a house or to a customer. Networks are built as a solid unit. They're not built one connection at a time. So as we're talking about networks, I just want you to keep in the back of your minds the fact that what we have here is something that looks more like that tree on the left, and not this thing that we see on the right, which is all these various connections coming out of a single place. Okay, so what we're going to see in the next few slides is a little bit more detail about how this network is designed. We've got essentially starting from the top, we have our customers that we're serving, and the networks kind of start coming into focus and start grouping together as they start coming into the branches down to that central office or that network operations center, whatever it is it's being called, that's being connected to a single trunk or maybe just a larger connection out into interconnecting to the outside world. The outside world having their own connections that are that we're connecting to with this network. And so that's kind of what we're seeing here. So let's kind of dive into each of these various sections. Again, we're going to start again from the top and move our way down. The first one is, and you might actually already be kind of familiar with this, is what we call a local area network. And this is what you tend to think of when you think about your connectivity. These are the connections within a home or within a location. And so your house may have a bunch of different various connections to it. You might have your computers. If you have smart home technology, you might have maybe some cameras, maybe a thermostat, maybe some electronics. They're coming out with some, refrigerators that are connected to the internet these days. All of those things are connected within the home to a router. And so that would be like a local area network. They might be connected with a cable. They might be connected over Wi-Fi, but it's that connection to that router that's the key here. Same thing with your cell phones. You may even have cell phones that are on the Wi-Fi. If they're on Wi-Fi, they're connecting to your home. Okay, so that's the local area network. So everything's connected to that router. And then we get to what we call the access network. And the access network is what happens after the router. This is the part of the network that your service provider makes available to you. So, that could be Verizon, that could be Spectrum or Charter. There's Frontier, there's People's Rural Telephone Cooperative. There's all kinds of various providers that provide that connection. And basically what that is the connection from that LAN, from that local area network to their central office, okay? We call this that local network. And so you may hear that term being thrown out there. You might hear access network. You might hear that local network. You might even hear something called a loop. Though all of those various terms refer to this part of the network here, okay? So once it is all kind of brought back to that central office, all those branches coming into the trunk of the tree, what happens next? What happens next actually is called a middle mile network. And this is that connection that the service provider has to the rest of the world. And so it basically connects their network to all the other networks that are out there. Okay. And there are various configurations and ways that they go about doing this. So I don't really want to get too caught up in those details, but I do want you to be aware that when we're talking about the middle mile network, we're basically talking about that trunk of the tree. Okay. And that's what connects our network to the something we're going to call the wide area network or the internet. It's the part of the network that goes out to the outside world and connects with where everything else is housed, everything else is located. So we're going to call that global wide area network, or WAN, is what we're talking about here. And that is the internet. So the internet is not a destination. It is not a thing that you just tap into. It is various networks. And we're going to talk a little bit more about what that looks like as we go along. But I want you all to be thinking about the fact that basically what it is that tree, has the roots that tap into other networks, that tap into other root systems. Here in Colorado, where I live, that Pam mentioned, we have trees called the aspen trees. You may be familiar with those. And the thing that's interesting about aspen groves is that they all share a root system. The internet is very much that same way. Basically, we're all tapped into the same root system. And that is how we have access to each other's information, and we can share information. And that's essentially what that internet is just the sharing of information. Okay. So to sum it all up, you have all these various elements of a network that essentially allow access to the internet. We have that local area network. Again, that's your home-based connection. And then from there, we have a connection into our service provider's hub or central office or network operations center, whatever you want to call that. And then from there, we have a middle mile network that gets us to that backbone network, to that internet access. Okay. So broadband, let's talk about what that is. Broadband is essentially the technology that we use to get access to that network. It's the physical connections that make internet access possible. So if the internet is the sharing of information, broadband is the facilitator for that sharing. It's how we are connecting, okay? So broadband is essentially that ability to transfer large amounts of information or data over telecommunications networks very quickly. There are wired networks and there are wireless networks. And wireless, we can be talking about mobile networks, we can be talking about fixed wireless, we could even be talking about satellite. But as we're going to be talking about in just a moment, even those wireless networks still require a wired connection, okay? And then also, not all networks are created equal. There are differences between some of these networks. There are trade-offs based on what kind of technology that you're using in order to connect to the internet. So we're going to talk about those in just a moment. But before we get too far down into the weeds here, I wanted to take just a quick moment and explain a couple terms that you're going to hear a lot as it relates to broadband. And we need to know what these definitions mean first before we can start comparing and contrasting some of these networks. So the very first thing that you hear a lot when you hear broadband is you hear speed. All we usually know as a customer is that more speed equals better, right? But what is it that we actually mean when we're talking about speed? Speed is basically just how much information can be delivered to you per second. Okay, so if you think about that network connection as coming through a funnel, and the larger the funnel is, as we all have experienced in our lives, the more of something that you're trying to deliver can come through. Okay, so let's just talk about, for example, sand, just as an easy example. Okay, so when we talk about speed, we're saying that we're basically talking about how much sand per second can go through that funnel. So the more speed that we have, the bigger our funnel is, and the more sand that we can get through at one time. And of course, the inverse is also true. The lower our speeds are, the smaller that funnel is, and the longer it takes for that sand to come through. Okay, so that's what speed is. Latency is essentially how long it takes data to travel from one place to another. Remember, the internet is a connection of various networks, okay? So it's not a destination, it's not a place that we go to, it is a network that we're interconnecting with. So when I push a click button on my mouse and I say, go to this web page, what ends up happening is my device sends a signal to my router, and the router communicates that signal to the internet service provider's broadband network, whatever that hub is called. And that network hub then sends that signal through the internet to the server where the data I've requested is housed. So basically what happens is that, again, we're not dealing with a single destination. We're talking about a series of servers all across the world where information and data is being housed. If I send essentially a request for that information, it travels all the way to the server. That time that it takes from my signal click saying, please send me that information to the server getting that is called latency. Now, often we talk about latency in terms of round trip. So what we typically are meaning when we talk about latency is how long did it take it from the time I pushed click on my mouse that we went all the way to the server, got the information from the server, and then it showed up back onto my device. That is round trip latency. And that is something that, that we measure when we talk about the differences between some of these networks, okay? So now that we understand what speed and latency are, we understand what broadband is, let's talk a little bit more about the various kinds of technologies or what broadband is made of. And one of the first things that broadband is made of, because it really originated with these communications networks, is copper, because a lot of phone systems were initially designed using copper. And so we'd have these copper networks. We would use electrical signals across the copper in order to deliver voice services. And that has been used historically to offer internet or excuse me, that broadband service, okay? I'm not going to spend too much time talking about copper. It's one of those technologies that's still out there. We still use it today. But generally speaking, we're starting to move away from it as an industry, all across the industry, regardless of where you are, because of various reasons that we're not going to go into right now. What I really want to focus on instead is a discussion about fiber connectivity. This is really more where the future is. Fiber, rather than using that electric signal, excuse me, it uses light to share that information. We basically have light that goes through strands of glass or plastic pipe that are as thin as a human hair. I'm really excited. Keith is actually going to show you all a little bit about what that looks like later. So if you are having trouble envisioning that, stay tuned. We've got that for you. So that fiber connectivity is replacing the copper out in the networks when we're talking about some of those wired networks. So one of the things that you may be thinking to yourself is, okay, well, if there's all these wires everywhere that's connecting everything, where are they? There's various places that these are kept, but most common, obviously, is aerial. Well, it's most common in some areas, I should say. It makes some sense in some locations, maybe a little less sense in others. It just kind of depends on how that network is being designed, the geographic issues that may arise. But essentially, if you look at a pole, if you are wandering around someday and you're taking a look at various poles, you may see lines on a pole. Those very first kind of top lines up there, those are electric lines. The ones down at the bottom are those telecommunications lines. And they're usually a fairly large cable that have a black insulated sheath that are covering them. So you might see them, they're a little further down on the pole typically. And so that's when you talk about aerial or you talk about poles, this is what we're talking about. We're talking about lines on poles. And again, the reason why you might do that is, there are places in the country, for example, where there's a lot of rock in the ground that it would make it very difficult to put something underground. However, where it makes sense to do so, you will find some of those connections underground as well. This might make sense in areas where you have, maybe some weather issues where, let's just say you get a lot of ice in a particular area and ice builds up on those lines and that can cause some issues. So you might want to put it underground instead. There are various reasons why companies might do things differently. Again, just kind of depending on what's required of them. And so there are various places where you can find those. So at this point, I'm sure most of you are thinking, well, but Stacey, I have a cell phone and I don't really use all of that stuff. So how does my cell phone work then? I'll give you a hint. It's not magic. Essentially what happens here is when you have a cell phone and you're at your home or you're at your workplace and you connect to that Wi-Fi, as I said earlier, your phone becomes just like any other device. It connects to your router, and then from there, it takes that physical connection from your router out to your ISP's hub, out to the internet. Okay, so it's a very similar thing to any other sort of device. Now, if you're not connected to your to a Wi-Fi, and you are using maybe an LTE signal, a 3G wireless signal, even a 5G wireless signal, what is happening is that you are connecting to an antenna. And that antenna is sending a signal to you, your device is sending a signal back. And essentially what we have here is a connection between your device and a tower or an antenna on a tower that's communicating that information. Now, the thing that's a little bit interesting here, and what I want to make sure that I point out, is that that antenna connection to you and your device, all that is just that last little bit of the connection. Once the signal hits that antenna, it is then transferred to wires. Again, probably fiber in most cases. And that fiber then goes to the central office, is then sent out into the world, into the hub, into that internet, to connect all that information. And then once we have that information that we got from the servers, it comes back to us, it goes to that antenna, and then the antenna sends that signal to your device. Okay, so it's really only that piece, that kind of last bit of that connection. If we're thinking about the tree again, it's like those twigs on the tree. Everything else is connected by wires. It's only that last little twig that gets us to the leaves that is actually wireless when we're talking about a wireless tower. So what we have here is kind of showing that very same thing. Essentially what we have is that handset connecting to the tower, and then there's that copper or fiber cable that's going to that mobile switching center, okay? That mobile switching center, again, we have tons of various names for lots of various, for all kind of the same sort of things, but they all kind of have the same functions. And so that mobile switching center is very much like that central office, very much like that network operations center that we mentioned earlier, okay? I want to pause here for just a quick moment and talk a little bit about how your cell phone connections vary. So I'm sure all of you have had experience at various times with your cell phone working or not working in various places as you're going about your days. And so the thing that I want to kind of talk about with cell phones is that your connectivity, your ability to access the internet using that sort of technology is going to be really dependent on a lot of various factors. And the first one is your distance from the cell tower. Basically, what happens is that when that antenna is sending out a signal, the further away it gets, the quieter that signal becomes. And so it makes it harder for the device to detect it. And similarly, the same way around. Sometimes if you're too far away, the device can be quiet for the tower and they can't hear each other, essentially, okay? So your distance from the cell tower makes a big difference. And this is actually really important, not just for LTE, but also especially for 5G. You're probably hearing about 5G already. If you haven't, I promise you will. There's going to be a lot of discussion about building out 5G networks. And 5G is a really promising technology that is kind of up and coming, essentially, in some of the wireless arenas. And basically what it does is it gives us a more bandwidth, higher speed, so that bigger funnel, which we are going to kind of need in areas where we maybe need a little bit more access for everyone, because maybe we've got connected devices, maybe we've got an internet of things that are happening, connected cars, all sorts of things trying to access the network. If we provide more capacity, more speed to everybody, then when they're sending their requests for information, they can get in and get out pretty quickly. And that's very helpful, right? One of the trade-offs when it comes to some of those 5G technologies is that the spectrum that they're utilizing doesn't go very far. You'll hear words like propagation. Basically, that's talking about how far that signal can travel, okay? And with 5G technology, it doesn't go very far. It only goes 500 feet. To put that in perspective, if you had an antenna on one end of the Capitol building, let's just say on the Senate side, if you put up a pole with an antenna and you sent a signal out, you couldn't receive it on the other side of the Capitol building. That's how short that distance is. And so that's a really important thing to be thinking about when we think about some of this wireless stuff. Again, they're all connected at the base with wires. And so you have to have all those various connections to all of those receivers, all of those antennas. Okay. So the other kind of thing, as I mentioned just a moment ago, when we're talking about the Internet of Things and various connections, you're going to have some constraints based on the number of users. Frequencies, and when we utilize spectrum, they can be impacted by how many users are trying to use that same frequency. All right, we have to kind of get in line to a certain degree when we're using that resource. And so your cell phone can be impacted by that as well. I already talked about some of the frequency issues and some of the considerations. Not all spectrum have the same characteristics. And so, that can be a factor as well, depending on what your service provider has access to. And then also, as you might imagine, obstacles are also kind of a problem. In my example earlier, I said, if we put an antenna on one side of the building, that really only works if we're on the outside of the building. If we go inside the building and we're having to go through walls and all of those sorts of things, those obstacles can kind of get in the way of that signal as well, as you might imagine. And then there's also environmental factors, obviously, or maybe not so obviously, but some of the wind and the rain factors can also impact your cellular connection. Satellites are a lot like that too. I mentioned them briefly earlier. And so, you're going to be hearing a lot about companies like Starlink, for example, who are putting out low Earth orbit satellites. There are things called geosynchronous satellites. And satellite technology is used for broadband access under certain circumstances. And we're just starting to see a little bit about how low Earth orbit kind of adds or comes into play here. But essentially, all of this is kind of the same. And it's rather similar to what we see with cellular networks. Essentially, if you look down at that graphic at the bottom, what you've got is you have your home signal. Sending a signal out to a satellite that bounces that signal down to a base station, an Earth station. And then from there, that signal has to go from the Earth station to a network operations center. And then from there out into the internet, we find our information on a server, bring it back, bring it to the Earth station. This Earth station sends the signal to the satellite beams it back down to the house. So there's a lot of steps that are involved in that connection for satellites as well. And kind of similar to what we see with wireless, satellite connections also depend on a lot of various things. The first one is physics, especially with those geosynchronous orbit satellites, those are really, really far away. And so the signal going from your home to that satellite, that's a really long distance for that signal to travel. And for the satellite to send that information to you, again, that's a really long distance. And so one of the things that you tend to see with satellite connections is a lot of latency. It tends to be the highest latency kind of connection out there. And so there's a lot of lag, which is really noticeable in real-time applications. So if you're trying to have a phone call, if you're trying to do anything that's in real time, you're going to experience quite a bit of delay if you're using those satellite connections. Also, another thing that is an issue when it comes to satellite here also is that very much like with the wireless networks, the number of users that are sharing a connection point also makes a difference. The more demand that's being placed on that satellite to send signals and receive signals and so forth, the more we're going to have to get in line. And just like what we have to do when there's a traffic jam, it takes a little while for things to flow through. And so that slows down the speed of delivery, slows down the speed of your internet. Frequency considerations are also available. There's obstacles, there's also environment. Environment is really kind of a big one when it comes to satellite as well. Cloud coverage can be an issue. Rainy days and snowy days can be an issue, not just because of the signal trying to break through those clouds, but also because of snow or rain building up on the infrastructure and causing issues as well. So those are some things to be thinking about when we're talking about the various kind of technologies that we use to access the internet. So let's just take a quick moment and let's talk about rural. I want to focus now on some of the unique challenges of providing broadband service in rural areas. And honestly, the biggest one by and large comes down to cost. Keith is going to talk in a moment about some of the amazing work that his company has done. And I wanted to use a little bit of an example here to give you an idea of why rural broadband has this challenge. So the cost of his construction was approximately $50,000 per mile. Okay. Now, rural areas obviously have fewer people. There's less density there. And so I looked up this statistic. The average population density of rural Colorado is about 6.8 customers per mile. So if we were taking that $50,000 that Keith had to spend in order to deploy his network and try to spread that across that 6.8 customers, and if we charge them roughly $90 for gigabit service per month, it would take us 82 months or about 7 years just to break even. And that only includes the cost of construction. That does not include any of the things that go into actually operating that network. So making sure that everything's hooked up and working. That doesn't include any of the connections to the customer's house. It doesn't include any of the equipment that we would need to send information to the internet, any employees to operate that network, ability to process customer payments or even pay our bills, any ongoing maintenance or upgrades. You know, maintenance happens, upgrades are necessary from time to time. It doesn't help us with any sort of troubleshooting or customer service needs that we may have. Simply putting that network out there into the world, it would take us 7 years just to break even, not even to make a profit. So that's a really big deal. And that also assumes that every single customer signs up, right? So there are so many challenges that go into rural, and really it's the high cost nature of providing that broadband network. So we all kind of understand that fundamentally, right? And so there are some various programs that are out there that help kind of offset some of those high costs. And the first one is the Federal Communications Commission Universal Service Fund. We're going to talk more about that one in just a moment because it's probably the most critical piece of making sure that broadband networks can exist in rural areas. Okay, so I'm going to talk about that one a little bit later. But there are other programs as well that provide additional funding for the cost of construction specifically. The U.S. Department of Agriculture Rural Utilities Service has loans and grants programs that assist network providers with putting those networks out there. There's also probably most famously right now anyway is the Reconnect program. And essentially what that does is it covers just the cost of construction for networks in areas that currently don't have access to broadband. Okay. So there's that program. In addition to that, the National Telecommunications and Information Agency has just put together or just received funding through appropriations, funding for a couple different funds. The first one is the Tribal Broadband Connectivity Fund, which is intended to prioritize broadband access and getting those connections out to tribal areas that are unserved right now. There's other uses for those fundings, but that's really kind of its priority. Similarly, there's a fund that's available for state and local government partnerships. So that public-private partnership is a term that you may hear here. And that public-private partnership might be eligible for some grant dollars through that program as well. So again, trying to get internet access through broadband networks where it doesn't currently exist today, okay? So let's talk a little bit more about that FCC program that I just mentioned. One of the things I want to point out is when the FCC was first conceptualized, was first kind of put into the world, The idea here was to provide to all people of the United States a rapid, efficient, nationwide and worldwide wire and radio communication service with adequate facilities at reasonable charges. The idea here was that we want to have all of the folks in the United States have access to a network. It's something that we call universal service. The idea and the concept here, has been kind of continued since then. We've had various telecommunications acts, the Telecommunications Act of 1996, for example, and they basically all say the same thing. We all benefit when we're all connected, when we all have access to communications networks. And so that's really kind of the goal here. And this whole thing kind of got formalized through various systems. And really in 1996, the 1996 Telecommunications Act, we formalized the Universal Service Fund. And the Universal Service Fund, essentially what it does is it provides support and funding for various priorities that we have in the program. And the first one is the high cost program. We also have a low income program, the schools and libraries program, and the rural healthcare program. Those are the 4 programs of the Universal Service Fund. The high cost fund program is made up of various funds within that program. You've got the Rural Digital Opportunities Fund, the Connect America Fund, the Alternative Connect America Fund, Alternative Connect America model. Some cost-based support mechanisms. There's an Alaska plan and rural broadband experiments. So all of those different funds all fall under this high cost program. We're going to talk about that again on another slide. These other 3 programs out here are also very important. The low income program helps offset some of the cost of service for customers who may not be able to afford it otherwise. Schools and libraries program, the intention there is to try to offset some of the cost that the school has to pay in order to get access to services so that they can provide the best level of education possible for their students. Rural healthcare, very similarly, the goal here is to provide support so that the cost of providing those services to a rural healthcare facility don't have to be completely borne by that healthcare facility, okay? So that high cost program, let's talk about that for just a moment. The one thing I really want to focus in here is that we talk a lot about the different programs and everything, but fundamentally they're all part of the same program. They all have the same goal. And the goal of that is to ensure access to broadband in high cost rural areas. Okay, now all of those different programs that we just mentioned on the last slide there have different features to them. Some of them are based on models. Some of them were distributed through auctions. It just sort of depends on the timing and, the location, frankly, of where the focus was at the time of those various funds that were being put together. Okay, so even though they may go about it in different ways, the goal is the same. The goal is to ensure that all rural Americans have access to the same level of service that you can find in urban areas at the same sort of price that you would expect to pay in an urban area. Okay. The thing that's a little bit interesting, I just mentioned on previous slides about those loan and grant programs out there. The goal of the Universal Service Fund and the high cost program is a little bit different because it's not just about getting the access out there, it's also about sustaining those networks out there. And so making sure that when you're serving in a high cost area, it might be prohibitively expensive for a customer to get access to the network if they had to pay for it all on their own. And so what this does is kind of offset the cost of that operation side as well. And so it's not just about obtaining broadband access, it's about sustaining it and sustaining it at reasonably comparable rates and ensuring that those rural Americans have access in the long term. So it's really the only program out there that's designed to be thinking about the business case for rural broadband connectivity in the long run. So it's a very important program for companies like Keith's in order to provide the levels of service that they do to their customers. And so with that, actually, I'm going to turn it over to Keith and have him share with you all a little bit more about how this works in the real world. Keith?
Thank you, Stacey. Great job in giving us some good information about broadband and what it is and how it works. And I'm not going to provide you with any slides. I'm just going to tell you a story about how our company does some of the things that we do with that broadband. I work for People's Rural Telephone Cooperative, or we like to call it PRTC for short. We're a nonprofit company. We're in southeastern Kentucky in the Appalachian Mountains. We have a population of the 2 counties that we serve, about 18,000 people. 900 is the biggest city that we serve. And our company started back in 1950 when there were no telephones in these areas, and we had to form our own company to provide telephones. Of course, we've come a long way since then, and now, we're in the broadband, the TV business, and even the wireless business. We have about 6,700 customers, about 50 employees, and as I said, we provide voice, video, and broadband, and we're also a partner in a wireless or a cellular business with 4 other small companies in Eastern Kentucky called Appalachian Wireless. So I'm a native of this area. I grew up in McKee, Kentucky, which is where our headquarters is. And most of my life, I hear people complain about what we don't have here. And there's a lot of poverty here, a lot of unemployment. We have no 4-lane highways here, no hospitals, no colleges, no railroads, not even a river. But we have some of the best broadband in Kentucky and in the country, actually, because we have built 100% fiber optic network to every single home and business in both counties. So we're not just gigabit cities, we're gigabit counties. And we've been that way since 2014. So we've actually, this is not something new to us. We've been all fiber for 7 years now. And it was, as Stacey said, it was a $50 million project, 1,000 miles of fiber. It was funded about 60% from USDA loans, 30% from a USDA grant, and about 10% with our own capital. And we're about 70% aerial and 30% buried. You saw the differences there. I want to show you just a little bit of, if you can see, this is a copper cable. This is what we used in the old days for a long, long time, probably 65 years. And this is probably a 50, what they call pair cable, that served about 50 homes. And then this is a fiber optic cable. This is 144 fiber optic cable. It's what we call a ribbon fiber. They glue 12 fibers together to make it easier to splice and maintain. And so this is what a fiber is, very, very light, and that could serve, the way we do it, serve up to 144 homes. And then here's just one fiber that would go into a home. We call it a drop wire, and you barely can't even see it. But as Stacey said, it's size of a human hair. It's glass, and you send light through it, and that's what makes this whole thing work so well on fiber. So we're 100% fiber. We've done away with all our copper, taking it all down. And it's amazing, we got this thing finished in 2014. We're like, okay, what are we going to do with it now? I mean, it's pretty cool that we got an all fiber network. What are we going to do now? And, we're just trying to improve our community. And one of the ways that we've done it, there are not many jobs here. And we were able to partner with some other folks, our county governments, our city, our local electric cooperative, and a group called Teleworks USA. And what they do is we have hubs here that we train people to work from home jobs, mostly in the service industries. So a group called EKSEP, it's a job creating program out of Eastern Kentucky. They started their first hub here in our county. And because of the fiber connectivity we had and good internet speeds we have, we can provide up to a gig to any home or business in our communities. And our 3 speeds that we offer are 100 meg up and down, 500 meg up and down, or a gig up and down, which is 1,000 meg. And all that's reasonably priced, anywhere from $39.95 to $89.95. And we've helped create over 1,100 jobs in the last 6 years with these telework hubs, work from home jobs. 1,100 jobs have been created through these hubs in my 2 counties. Now, throughout all of Eastern Kentucky, they've got about 9 of these hubs. There's about 3,300. So my 2 counties, a third of these jobs have been created mostly because of the good internet speeds that we have here and the good broadband. So you can think of it, 1,113 jobs. If you take them on the low end of what they might start out in, That's like $25 million of potential yearly wages. So you can see what a difference that can make in our community, in any community. If you had a brick and mortar factory with 1,100 jobs, it'd be a pretty big deal. And that's what we've done over a period of time here. And it's something we're really proud to be a part of. And another thing that we've done here, and of course that doesn't even count all the people that are working from home due to the pandemic. That's changed to where almost everybody works from home now. And you know, we have good broadband connectivity to where they can do that. We had the very first virtual living room in the country, and that was something that we were invited to the White House because of some of the things we were doing. We were selected as a smart rural community by NTCA, and they talked about some things to a rural health summit at the White House, some innovative pilot projects that could be done and so we came back to our community and said we'd like to be a part of that. So we partnered with our local library, and our local veterans hospital, which is about an hour and a half away. And we provided a place with good broadband and good privacy to where local veterans could come in to the local library and use telemedicine or telehealth to talk to their doctors and not have to spend a whole day going to the hospital. It's not rocket science or anything, but it was the first thing of its kind in the country. And there have been several others. I know FRS has grants to do things like that. And there have been several others throughout the community since then. And that's something we've been doing to try to help our veterans in our community. We work really closely with our school systems here. They've been connected with fiber for probably 20 years. When the pandemic hit, we quickly, said, what can we do to help? And one of the things we've done was set up some free hotspots, about 10 of them throughout our community. And if kids don't have broadband or can't afford it, they can come to that and help with their schoolwork. We've also done some discounted plans for people that are eligible for Lifeline. We're doing a $10, 25 meg plan for $10 if they're eligible for Lifeline, and if they have a school kid or if they have a work from home job. Another thing I forgot to say about the Teleworks USA is when they have a training program for these work from home jobs, and some of these people are working for Apple, some of these people are working for TurboTax or Hilton or whatever, but the Apple's some of the better jobs, some of the better paying jobs, and these folks are really proud to say they work for Apple living here in Eastern Kentucky. And but we give them, if they go through that training, we give them 3 months free of broadband, also free installation in order to help them get started if they don't already have broadband in their home. And even though we have this great network, there's still 28% of our customers don't have broadband because they can't afford it or they don't see the importance of it. So we've come a long way, but we've still got a ways to go. We have the free gigabit service to all the public libraries that we serve because we see that as giving back to our community. We're also, as I said, we're 20% owner of Appalachian Wireless. Appalachian Wireless is started by 5 small companies like us. It's now much bigger than any of the companies that started it. Yeah, they have like 300 employees and 300 cell towers in Eastern Kentucky. And I might add, almost all those towers are connected with fiber, as Stacey said, because it takes that to make wireless work. We also built a 370-mile fiber ring that connects all six companies in Eastern Kentucky and gives us redundancy and better access to the outside world. One of the things that was pretty cool about our building fiber project that we got some publicity about was we've got a lot of mountainous, rocky terrain here, and we had some pictures of one of our contractors had a mule that helped put up this fiber called Old Bub, and Old Bub's become pretty famous and synonymous with PRTC. And even a local guy in Lexington here wrote a song about Old Bub. You'll have to Google it. Old Bub's got his own song about building fiber in Eastern Kentucky.
I think one of those things that we're going to send out afterwards has got some information about Old Bub, doesn't it, Keith?
Yeah, Old Bub's, he's much more famous than me or PRTC, that's for sure. Let's see, a couple of things I don't want to forget before our time gets away. The last 5 years, we've actually branched out into some surrounding counties. People have learned that we have this great broadband, and in Eastern Kentucky, there's a lot of communities that don't have it. And so we branched out into 2 or 3 of our surrounding counties, and we've added 1,000 customers in competitive areas where we're competing with other people. And we're building fiber to the home there as well. actually using an Amish family to help build that fiber. So we went from a mule to an Amish family to build this fiber. We're sort of going back in time to get this state-of-the-art technology. And we use USDA to help build some of this in surrounding counties. We've been awarded some of the Reconnect loan grants, also Community Connect grants, and we've been a bidder in the RDOF as well. And all of these USF funding components, high cost, lifeline, E-rate, they're very important. They're critical to our company because they help us be able to sell services that people can afford. And one of the things I like to talk about is, you know, we're not just a broadband provider here. We're a community-minded company. We're a nonprofit. We're trying to help make our community a better place to work and live and giving back to our community. And I'm a huge baseball fan. When I was a little boy, my hero was Roberto Clemente, played for the Pittsburgh Pirates. I don't know if any of y'all ever heard of him or not, but he not only was he a great baseball player, but a great humanitarian. And he's in the Hall of Fame. He has 3,000 hits. And in 1972, I was in college, and there was an earthquake in Central America, and he lives in Puerto Rico, or he did. And he got on an airplane to bring supplies for those earthquake victims, and he died in an airplane crash on the way to do that. And so, I mean, he died like he lived. He was a great humanitarian as well as a great baseball player. But one of his famous quotes, I'll end with this, is, you know, if you have a chance to accomplish something to make life better for others and you don't, then you've wasted your time here on earth. PRTC don't want to waste their time here on earth, and I don't either. We're trying to do something to make life better for others here in our community. And I think we're doing a decent job of it, but we want to continue to do more.
Thank you, Keith. Thank you, Stacey. Thank you, Keith. If you have questions, feel free to type them in. I have a couple questions to get started, if you don't mind. One of the questions, there's a lot of talk these days about 5G. And, you know, we see these full page ads about 5G is coming to your neighborhood. Is 5G going to rural communities? Is it not a big deal? Is it a big deal? Can you just talk a little bit more about what that really means? Maybe Stacey, you can start, and Keith, you can say what is happening in Kentucky.
Yeah, sure. Thank you, Pam. So, you know, one of the things we talked about when we talked about with wireless and 5G is that lack of propagation. So, you know, it takes a lot of fiber to make 5G work, as Keith mentioned. And so, in rural areas, because distance is the problem that we're trying to solve, and the density of, or the lack of density rather, of customers, 5G doesn't have the same amount of applications in rural areas as it does in urban. It's really good for areas where you maybe have a lot of devices or people wanting to access the internet very quickly. And less about necessarily getting connectivity out to some of the rural areas, because again, that capacity is not really the issue. It's the distance that's the issue. And so I'm not saying there aren't any applications for 5G in rural areas. There are, but it's going to look different. And some of what I'm seeing, at least, is that we're probably not going to see 5G in rural areas for a while yet.
I was getting ready to say the same thing. It looks like it's more of an urban solution than a rural solution. It's going to take a lot more time and a lot more money to do it in rural areas. But our wireless company's talking about 5G and trying to prepare for it, but it's going to be a challenge. The footprint of those 5G towers is very, very small. It's going to take a lot of them, and there's a lot of mountains in the way in Eastern Kentucky.
So is that the same answer for, well, if we don't have 5G, we can just use satellites and everybody will be happy?
Well, the issue that we have with satellites, again, is that they have a kind of a similar issue with a lot of folks trying to get onto them and having to share that pipe essentially between you and that satellite. If your entire neighborhood is trying to access information at the same time, that's going to be really difficult and slow down. And there are actually some engineering studies out there that show that even with some of this newer technology that we're talking about in those low Earth orbit satellites, that if you start getting too many people on those networks, you're going to have so much congestion that it's going to really reduce everybody's experience quite significantly.
The solution, Pam, is to have fiber to every single home of business in America.
No problem.
Might be expensive, but that's the solution.
And if I could just also, you know, it's not even, I just want to make sure that I'm clear too, that, you know, I'm not saying that satellite or the wireless don't have a place. They certainly do. I have a cell phone just like everyone else. But, you know, they're complementary to some of these fiber networks, and where we can do fiber, there are definite advantages to doing so.
Keith, you mentioned a little bit about how the pandemic has impacted your community and people working from home and people needing to go to school. Can you talk a little bit more about how, as a company, you've experienced some changes and people are using your services differently? Or are they?
Yes, definitely. I mean, our lobby's been locked since March. Nobody's coming in, and we're doing all our business either through drive-through windows or through electronically or on the phone. And of course, we're still having to send service people out to install broadband because the demand for broadband is even bigger because of the pandemic. And it's been a challenge to try to keep our own people safe and yet deliver that service that's so desperately needed for people's education and their jobs and their health care. And we've had to change a few things and continue to be flexible. And of course, we're small enough that that's relatively easy for us. You know, we make our decisions here locally, and they're not made in some other state by some, you know, stockholders or whatever. But it's been a challenge for us. And of course, you know, so many people are working from home now that weren't. I mean, we've been working on getting jobs for people working from home for a long time, but so many people are working from home, just like probably you two. And I've worked from home some myself, although I live within a mile of my office, so I come in a lot of times. But it's a challenging time we live in. But our actually community was in a better shape than a lot of places because some of the surrounding areas that didn't have good broadband have really struggled, and we've really been bombarded with phone calls and people saying, "Can you guys serve us?" And of course, you know, in some cases the answer is yes. In some cases, it's not at this time.
So I don't mean to ambush you, and I didn't warn you of this, but if there was one thing you wanted people to take away from this session when they think about rural broadband, what would you like that to be?
Is that me or Stacey?
Either one. You can go first, Keith.
I would echo one of the things Stacey said, the importance of the government programs that allow companies like us to do state-of-the-art broadband. That's what people in rural America need, just like people in urban America. And, you know, whether it's from the FCC, USF, or USDA, or any of the other programs, our company's taking advantage of all of them, and we need all of them in order to make the business case work. And it's critical. And, you know, without that, we're not going to have, there's going to be even more of a digital divide than there is now.
Thanks. Stacey?
Yeah, I think probably the most important thing that I would say is that it's not just enough to build a network. We've got to sustain those networks where they exist. And so having programs in place that allow for that sustaining of those networks, making the services more affordable, are really, really critical.
Well, thank you both. Thank you all for attending this session. To reiterate, following this, we will send you an email with a link to the recording in case you wanted to go back and look at something or send it on to somebody else. And also a couple other resources where you might have some information, including the article or there's a about little Bub that Keith mentioned, and also contact information for both Keith and Stacey and FRS, but Keith and Stacey. And we're grateful to all of you. Let me make that you attended today. I hope you found it helpful. And if it was extremely helpful, maybe we can do something similar or get into depth in a future session. So thank you again, Keith. Thank you again, Stacey. And thank you all for joining us. Take care.
Thank you.